Welcome to MathSol. In this video, we are going to look at the modification of trigonometric function. Particularly, we are focusing here for sine and cos. And if we start with the general form of the sine function or sine or cos wave, what is that? That sine wave is y equal to. We can just start writing it. Y equal to a sine um, bx plus c in a bracket then plus d. So it means if we look at a is for amplitude, and amplitude is always be positive, right? But we will talk that it will start with the y equal to negative of something, but this is we'll explain later. But amplitude, usually we have a amplitude is a absolute value which is positive, and by changing the value of a, we are actually modifying the graph based on the amplitude, and it will just, you can see the graph is stretching like that direction. So b is associated with the period, so it means you know that the usually the period is twice pi to complete the whole circle. But in this case, if you use a period, if we have any number sitting before x, that the period will be modified, so it will be twice pi over b. Okay, so whatever the value is sitting there, we have to just divide by that. Then c is associated with the phase shift, and how to calculate phase shifts, I can just write down phase shift. So for phase shift calculation, we have to just take this one, bx plus c equal to 0, then you can get x equal to minus c over b. So this is actually representing the phase shift. So it means the graph starting from the original starting point, which is 0, so it is starting from the little bit forward or backward, and how much forward backward we can calculate by using this formula. Okay, and what is d for? d associated with vertical shift. Vertical shift. And as I mentioned, a is associated with amplitude. Okay, so vertical shift, it means the graph, you can see the graph is moving. So phase shift is graph moving left, right, and when we are talking the vertical shift, graph starting from the up or step down or step up from the original x-axis, and that's what we will see. So particularly in this video, we are going to focus on the amplitude change. So by changing the amplitude or value of a, how the graph can affect, and even if we have a negative start with the y equal to negative of that function, then what will it will affect in the original function. So let's say that we can start with the very basic graph, which is y equal to so I'm just writing here, let's say we have y equal to sine x. If you remember that how to plot y equal to sine x, probably I just use the black color. Yeah, so y equal to sine x, you know that this is our x, this is our y. Okay, and then when we are doing sine x, you know that our period is twice pi, so it means one complete circle will be completed in twice pi. So it means we have, you know that in the complete circle we have 4 equal segment or 4 critical point here for each quadrant, and you know this is 90 degree. For every 90 degree there is a quadrant, right? So and then total is twice pi, and then this one, if it is a pi of you know that this is the midpoint of twice pi and 0, and that definitely will be pi. And then if you go from pi and twice pi, what is the what is the, this is 3 pi over 2 is always multiply this first one by 3, that gives you third one. So this is pi over 2, that will be 3 pi over 2 multiplying by 3 for the first one. Now this is our scaling, so you know that our complete circle will complete it from 0 to twice pi, okay, for the one per circle. Now amplitude, you know, when we are talking the y equal to sine x, our amplitude is 1, so we are drawing the graph from 1, and then lower limit will be -1. And you know the sine graph starting from 0, then going from maximum value, coming down to 180, okay, and then coming at 270 degrees, coming to lowest point, and then coming to 0 again at 2 pi. So if you just mark the graph, it will be like that. That's the sine graph. Okay. Now we are, this is sine, I will write down later, but now we are trying to show what will happen if we change the amplitude. And you can see in this case the amplitude is 1 because 1 sine x. If I say no, we are trying to plot 2 sine x, then what will happen? So it means we are changing 1 to 2, our amplitude is going to be 2. So it means our upper limit here, it will change amplitude, instead of 1 it will be 2. So you have to go up to here, right? So same way in the negative side also we have to go -2, right? Now it means our period is not changing because we have still sine x, so there is no b here, like b is 1 here. So now what we need to do, we are just changing the amplitude, and it means we just need to, so our starting point same, and it is coming 0 here, it is coming 0 here, but the maximum point will be here and the minimum point will be here. So it means you can see the graph will be just bit elongated in that, so it's stretching up like that, right? So you just connected these points and then connected like this and then connected like that. Okay, so that's how you can get the sine of 2x. So if I just write, this is our for sine of 2 of sine x, and the other one is just original one, it's a black one. I can just write, and this is our sine x. So you can, I am just putting in the same graph so you can see how that changed, right? Let's look at another example. For example, we are plotting a graph which is with the base again y equal to cos x, right? So in the second one I'm just trying to show you y equal to cos x, and again this is our x-axis and this is our y, right? Now if you remember correctly, that cos x, again period is the same because it's a cos x, so b equal to 1. So if you put b equal to 1, you can see period is 1 in here. So now we get, again we have the same scale, like we have to go up to twice pi and equal 4 segment here. All right, you can see exactly the same scale here. So pi over 2 pi, and this will be 3 pi over 2. Okay, now you know that cos starting, and this is from 1 and to -1, that's the amplitude here 1, and we start amplitude 1 because you can see the coefficient of cos x is 1, and we start from maximum point when we are doing cos graph, and then it is coming to 0 at 90°, then it is going to lowest value at 180°, then it is going up like that at 270, again it's coming 0, then it's going to maximum at 360°, and this is, you can see it's a complete circle, its circle is completed here, right? So if I just connected this dots, yeah, that's a complete circle, and that is for cos x. Okay, now what will happen if I do another graph just putting on it? So y equal to, let's say it's a minus cos x. Okay, y equal to minus cos x. I just need to that I just keep that space free. Okay, so I'm just drawing y equal to minus cos x here. So in that case what will happen, you know that that minus definitely cannot say amplitude is -1, the amplitude is still 1, amplitude is still 1, so we are just, our highest point or lowest point will be -1, highest point 1. But what that will do, that negative will do here, it will just think that y is getting negatives. Wherever before y is positive, now it's negative. Wherever y was negative before, it will be negative, negative will be positive. So it means the positive will be negative, negative will be positive. That will happen here. It means the graph is just reflecting along with the x-axis. The graph will be reflecting along x-axis. So because where before is starting from +1, now we have to start from -1. When it was decreasing, now it is increasing like that, and then when it is 0, it is 0, coincides here, and then when it is -1, it will be +1 here. So the graph will be like that, and then when it's 0, again it's coming to 0 like that, and then after that it was maximum at 360°, that it is coming minimum at 360°, So that's what is changing. So it is just reflecting. So that negative, the function of that negative sitting in front of that function is just reflecting the graph along with the x-axis. That will happen. Now, do I always need to stop in 2 pi? Not necessarily. If the graph asking to plot you from 0 to twice pi, yes, you have to stop here. But if there is no restriction on the domain part, you can just keep going, keep continuing. So if I continue, for example, doesn't matter if I go negative side or positive side, it will happen the same thing. You know that 4 equal segments here for each circle. So if I go back side, another complete circle will be completed in this up to here. So back, because this will be negative 2 pi and this is 0 and negative 2 pi, so that will be another circle. If we go forward direction, again is possible. 2 pi to 4 pi will give you another circle. So if you continue the circle, you can see that it just, you need to extend the graph like that, right? It will be just going, then you see at minus 90, you see it's coming 0 here at minus 90 degree, and then minus pi, this is minus pi over 2, this is minus pi, this is minus 3 pi over 2. So the graph, you can see the same pattern, it just copy, right? So it is just coming like that, then and then it will be just coming here. So and if you look at here, you see just copy, then again going and coming down, and this coming down at 2 pi. So that's how you can continue in either in the left side or right side, up to you. Same way you can continue for the original graph, which is cos x. If I just write down, this graph is our cos x, and then the blue graph is our minus cos x. I'm just putting in the same graph so that you can see the difference for putting positive cos x and negative cos x. Thanks for watching. Please subscribe my channel to see more up-to-date videos.